to episode 5 of Cloud Tech 10 for the 10th of April 2017. I'm Mark and I'm going to tell you all the latest news about Microsoft Azure from the past week in 10 minutes or less. It's now really simple to integrate application insights with Azure Functions, thanks to an update that's been made to the beta version of Azure Functions. First, create a new application insights instance in Azure. When doing so, make sure to set the application type to General. Once the deployment is complete, we'll need to grab the instrumentation key. This is how we hook up an Azure function with application insights. I have two simple functions running in Azure. One is a timer triggered function that fires once per second and writes a message to an Azure storage queue. The second reads the messages that are placed onto the message queue. To integrate with application insights, I open my Azure Functions instance and choose Configure App Settings. Next, I add a new app setting named app insights _ instrumentation key, and I set its value to the instrumentation key that I copied earlier from application insights. Because this feature is currently only enabled in the beta version of Azure Functions, I need to modify this functions extension version setting to the value beta. And that's it. Just those two simple changes and my Azure function is now integrated with application insights. Let's leave things for a while so we have some data to play with. Okay, it's now 24 hours later, so let's explore application insights. I can see server response time, server requests, and failed requests in the charts on this overview page. If I click on live stream, I can see a live view of the incoming requests and overall health of my function app. I can also go to the analytics portal, which gives me access to more detailed charts and a powerful query language to extract the information I require. The query editing tool in the portal features IntelliSense, which makes it easy to enter your own queries, with suggestions being provided as you type. You can also pin favorite queries to the Azure portal's dashboard. The other useful feature of application insights is the ability to create alerts, so that when certain conditions are met, an administrator or an enterprise monitoring application, for example, could be notified. Azure Container Registry is now generally available. If you work with Docker containers, then you'll know that containers need a registry service that stores your container images and integrates with your DevOps workflow. The Azure Container Registry allows you to maintain a private Docker container registry, which is often an essential requirement for organizations who don't want to place their containers into a public registry. If you already use virtual machines in Azure or other services such as the Azure Container Service, Service Fabric, or Azure App Services, then using the Azure Container Registry makes it possible to keep your images in a geographic location that's close to the resources that make use of those container images, thereby reducing latency and ensuring container images can be downloaded and run quickly. Setting up Azure Container Registry is straightforward. It can be done from the portal or via the command line. In this instance, let's set up a new container registry via the Azure portal. I'll start by searching for the container registry. I give the new registry a name, resource group, and location, and a storage account that will be used for the container images. Click Create, and after a few moments, my new container registry is ready to use. The Quick Start tab provides a handy reference using the Docker Hello World image as an example. To show how easy the Azure Container Service is to use, I'm going to create a new image for a Node.js application and deploy and run it on an Ubuntu server. Here's my Node.js application. It's a simple Hello World application that normally runs on port 3000. I have a Docker file which is used to build and configure a new image. In this case, I'm starting with a Node base image which will be pulled from the public Docker Hub registry. I'll then create a folder inside the image to store my Node.js application. Copy the files that make up my application to the image and run the Node package manager to install the packages that the application requires. I provide the command line that's needed to run the application and note that the application runs on port 3000. I've made this application on a Windows 10 computer running Docker for Windows. So I'll now run the docker build -- tag hello node, that's the name of my application, and a dot to indicate that the files we want to build are in the current directory. You can see that the Docker file is being processed and the steps we saw just now are being executed. Okay, my Docker image for the hello node application is now ready. Let's deploy it to the Azure Container Registry. First, I need to authenticate with the registry using the docker login command. Next, I tag my image with the name of the Azure Container Registry instance that I'm going to use and the name of my application. And now I push my image to the Azure Container Registry, again specifying the name of the registry and the application. And after a short while, the process is complete. I'll now return to the Azure portal, and within the Azure Container Registry, let's select repositories, and we can see the Hello Node application that we just uploaded, and if I drill down further, I can view the manifest. Now I'll switch to my Ubuntu server. Again, the first thing I'm going to do is log in to the container registry. I use the docker pull command to retrieve the image from the container registry. And in the same way that I did when we uploaded or pushed this image, I make sure that I specify the container registry name and application name. After a few moments, the pull is complete, and the image is now downloaded to my Ubuntu server, which I can confirm with a docker image ls. Let's start a Docker container using this image. Docker run -d to detach and run this in the background, -p, and I'm going to set the ports here so that although the application is running in the Docker container on port 3000, it will be accessible via port 8080, and then the name of the registry and the application. Okay, that looks good. A quick Docker ps, and we can see that the container is now active. So our Node.js application is running. To prove it, let's open a web browser, enter the public IP address of the Ubuntu server and the port 8080 that we told the container to use, and there's our Node.js application. Azure Stack Technical Preview 3 has been refreshed and new PaaS services added. TP3 was released at the beginning of March and added a whole host of new features. TP3 is the final preview release before Azure Stack's expected general availability in the middle of 2017, with refreshes to TP3 adding new features between now and then. In this refresh, event-based serverless compute comes to Azure Stack with the addition of a preview of Azure Functions. There are also updates to database services, with MySQL moving to version 5.7, various improvements to the installation and deployment of Azure Stack, and improvements to service reliability. Azure HDInsight version 3.6 is now generally available. It features the latest Hortonworks Data Platform 2.6 release and also includes updates to other components. Apache Spark version 2.1 is available and introduces the ability to support real-time streaming via Azure Event Hubs, allowing you to analyze millions of real-time events with Spark. Apache Hive version 2.1 is also part of this release and enables ETL that's twice as fast, and an updated preview of Interactive Hive, which enables 25 times faster queries and sub-second performance. Hive View 2.0 is included, providing an easy graphical user interface for developers to get started with Hadoop, and HDInsight 3.6 now pre-installs the Zeppelin notebook. xEvents can be used with Azure Analysis Services for scenarios including troubleshooting and diagnostics, detailed auditing, and usage analysis. xEvents for Azure Analysis Services are configured using SQL Server Management Studio. I start by providing the server name for my Azure Analysis Services instance. Once I'm connected, I expand the management folder and then extended events. If I right-click on the sessions folder, I get the option to create a new session. After providing a session name, I can choose the events that I want to collect. So let's add a few in here so we can monitor access and commands being executed. Next, I add a target type. At present, it's not possible to write xEvents for Azure Analysis Services to file, but there is a sample application available on GitHub, which demonstrates one way that you could achieve this. For the time being, let's select the event stream option. Click OK and we're ready to go. Let's right-click on the new session we just created and choose the option to watch live data. I've opened Power BI and I'm going to choose Get Data, then Azure, and then find the Azure Analysis Services option. As I enter the server name for my Analysis Services instance and start to select the model I want to use, you can see behind that extended events are being collected. Now in Power BI, I'm going to add this city field so I can visualize the cities in my data on a map of the world. Back in SQL Server Management Studio, I can customize the columns shown in my live data view. Let's add a couple more. So now we can see the application that the request was initiated from and the data that was sent. We can see here where I used Power BI to add city information and the query that was executed. Up until now, the use of Java with Azure Service Bus had somewhat limited support. The Azure SDK for Java and Apache Cupid Proton J were two available options. However, both had pros and cons. Now there's a preview release of the Java Service Bus client, which aims to provide feature parity with the .NET client for Service Bus. The new client is open source and available on GitHub. Since August 2016, the Azure CDN from Akamai has provided support for HTTP 2. Now this support has been extended to Azure CDN from Verizon, so all Azure CDN customers can now benefit from this. This feature is on by default, so no action is needed to enable it. HTTP 2 aims to update and replace the HTTP 1.1 protocol that has been the default on the web for over 15 years. HTTP 2 is better suited to today's websites, which tend to be more resource intensive than those that were around 15 years ago, and adoption of HTTP 2 should mean faster websites for everyone. That's all for Cloud Tech 10 this week. Don't forget, tell your friends, like, share and subscribe, or follow me on Twitter. I'll see you next week. Cheers for watching. Thanks for watching. If you enjoyed this video, don't forget to like, share, subscribe and follow me on Twitter for more.